Alright, so far we've used two methods for solving systems of equations. The first is solving by graphing, where we graphed both equations, found where they crossed, and then this was our solution. So we did Virgin Mobile and Sprint in that example. Then we learned how to solve by substitution. So I said, okay, if x is equal to y plus 7, then everywhere I see x in this other equation, I'm going to put y plus 7, which allows me to only have one variable, so I can solve for y. Once I find the value of y, I can put it back into one of those equations, and I end up being able to find x. Today we're going to learn a new method called the elimination method. And this is really useful in certain situations, and I'm going to explain which situations those are. So the first thing that we need to understand to be able to do elimination is that in this equation, 2x plus 5y equals 17, this left side, 2x plus 5y, is equal to 17. I mean, I know that's kind of obvious. It says it right there. But the reason why this is important is this. So we all know that we can add, say, 10 to the left side of an equation and 10 to the right side of an equation. We always have to do the same thing to both sides. Now, here's the weird thing. Because 6x minus 5y is equal to negative 9, I can add 6x plus 5 or minus 5y to this side of the equation, and I can add negative 9 to this side of the equation because they're equal. I'm doing the same thing to both sides. Now, you might say, wait, what are you talking about? Here's what I mean. I'm going to add 6x minus 5y to the left side of this top equation and negative 9 to the right side. So I'm going to add 2x plus 6x, sorry, which makes 8x. And then I'm going to add 5y and negative 5y, which makes 0. Bring down my equal sign, and then I'm going to add 17 and negative 9. 17 minus 9 is 8. Now, an interesting thing happened here. All my y's disappeared. And if you remember in our substitution method, when we're trying to solve an equation, we first need to get rid of one of the variables so we can solve for one, in this case x, and then we can solve for the other one. So now I have 8x equals 8, and just like before, we can quickly divide by 8, and we get x is equal to 1. Now that I know that x is equal to 1, that. Now that I know that x is equal to 1, I can plug that back into either one of these equations. So I'm going to plug that into just this first one, but either one would work. So 2x plus 5y equals 17. And in place of x, I'm going to put 1. So I'm going to substitute 1 in for x. Now I get 2 times 1 is 2, plus 5y equals 17. Can subtract 2 from both sides. So get 5y equals 15. And then divide both sides by 5. We get y equals 3. So then my solution is 1, 3. Now, I said that this is useful in certain situations, and the reason why this worked this time was that we had a positive 5y in one equation and a negative 5y in another equation. So when those two add together, they make 0, which is why this works. That's why it's called the elimination method, because we just eliminated all of the y's. We could do the same if there were x's that matched up like that also, like 2x and minus 2x or something like that. Alright, now sometimes, like in this case, I see I have y here and y here, but they're not opposites. One of them isn't negative. So if I added them together right now, it would give me 2y, and that's not what I'm looking for. But one thing that I can do, just like always, is I can do operations to either side of this equation. And in this case, all I really want to do is change the sign. So in the second equation, I'm going to just change the sign of everything. So I'm multiplying this left side by a negative, and then multiplying this right side by a negative. Now, why is that helpful? Well, let's check it out. Now I have 2.5x minus 1x, so I end up with positive 0.5x. Oh, sorry, 1.5x. And I have positive y and negative y, which make 0 again. They're eliminated. And then 164 plus negative 101 is 63. Alright, so now I can divide both sides by 1.5. So we get x equals 42. Now that we know what the value of x is, we can plug that back into one of these two original equations. I think I'm going to plug it back into the second one because it's simpler. X plus y equals 101. And so then in place of x, write 42 plus y equals 101. And then I'm going to subtract 42 from both sides. And I'm left with y equals 59. So my solution is 4259. And if you want, you could also write that like this. So when we have two equations that have the exact same number of y's or x's, we can change the sign of everything in one equation so that the y's or the x's cancel out. Both of the examples that I've done, we've canceled out the y's, but you can just as easily do it with the x's, so make sure that you check which one is going to be easier to cancel out. Alright, try this one on your own. The solution is -9, 2, so you can check your work when you're done. Again, you can eliminate either y's or x's. In this case, I think the x's look a little bit easier. Pause the video now. Alright, when we add these together, -5x and 5x make 0, -9y and +8 make -1y, 27 minus 29 makes -2. Divide both sides by -1, and we're left with y equals +2. I'm going to plug this into the second equation because I like it better. It doesn't have so many negatives. 5x plus 8y equals -29. Now I'm going to take this, substitute for y, so I have 5x plus 8 times y equals -29. If y is 2, then I have 5x plus 16 equals -29. Going to subtract 16 from both sides. So we have 5x equals -45. Divide both sides by 5. X equals -9. So just like I said, the solution is -9, 2. So we can eliminate either x's or y's. In this case, I eliminated the x's because the coefficients were the same but opposite sign. All right, try this one on your own as well. Pause the video now. All right, so this one, because these both have a coefficient of 4, positive 4, I want to go ahead and change the sign of everything in this. I can really do it in either equation, but I can do it in the second one. So now I have -4x, -4y, and -16. If one of these had already been negative, then it would become a positive. So positive 1x minus 4x makes -3x. Positive 4y and -4y make 0. -8 and -16 make -24. So actually, I probably should have made all these other ones negative on the top, because then I would have ended up with positive 3x, which would have been a little bit easier. Alright, so now we're going to divide by -3, divide by -3, and x equals +8, just like our solution said it should. Now I'm going to use this first equation because I think it looks simpler. X plus 4y equals -8. Substitute 8 in place of x. Subtract 8 from both sides. And divide both sides by 4. Get y equals -4. Alright, try these 4 classwork problems on your own. The solutions are here so you can check if you did it right. If you get stuck, raise your hand or ask somebody next to you. Ready, set, go. When you're done, there's more examples. Alright, so we already went over how to, if we had two coefficients that were exactly the same, sometimes we needed to change the sign of everything, or if they had opposite signs, then we could just eliminate them immediately. Now, we can also multiply or divide everything in our equations by something as well. Now, so what I need to do is sort of think about where do I see a potential spot where I could eliminate things. And I see that here I have -4 and +8, and this 8 is just 2 times 4. So what I'm actually going to do here is I'm going to multiply this whole top equation, all of them, by 2. So I'm going to try that. I'm going to multiply it by 2, and then I'm going to put it right down here below. So -4x times 2 is -8x. 9y times 2 is 18y. And 25 times 2 is 50. So all I did was I took this equation and doubled everything, multiplied everything by 2. Now we can eliminate, just like we did before, because I have +8x and -8x. Those make 0. -10y and +18y. +8y. -10 and +50. That's like 50 minus 10 is 40. And now I just have a one-step equation. You can divide both sides by 8. You get y equals 5. Alright, so now that I know the value of y, I can take that and plug it into one of our original equations. We can really use either one, so why not -4x plus 9y equals 25. So we'll plug it right here. -4x plus 9 times y equals 25 when y has a value of 5. So now it's -4x plus 45. 9 times 5 is 45. Subtract 45 from both sides. -4x equals to -20. And then divide both sides by -4. And I'm left with x equals +5. So the only thing that we did differently here was that none of these matched up perfectly, so I multiplied one of the equations to make them match up. I saw +8x, and I wanted -8x, so I multiplied the first equation by 2, doubled everything, and then I could eliminate. Try this one out on your own. Here's the solution so you know if you're correct or not. See a -3x down here, so I figure I'll just multiply this equation by 2, and that will give me -6x minus 14y equals -18. So I'm actually just going to kind of scribble out this equation now so that I don't get confused. So now I have positive 6x minus 6x makes 0. 9y, -14y makes negative 5y, 3 minus 18, negative 15. Divide by negative 5. Y equals positive 3. Now I'm going to use that. I'm going to plug it into 6x plus 9y equals 3. So 6x plus 9 times 3 equals 3. 9 times 3 is 27. Subtract 27 on both sides. 6x equals negative 24. Divide by 6. X equals negative 4. So first I multiplied one of the equations so that I could get two of them to match up so I can eliminate them. I eliminated the x's here, so I was able to solve for y. I substituted y into one of the equations, and then I could solve for x. Alright, so here's part 2 of the classwork. You can do these on your own. The solutions are there so that you can check that you're doing it correctly. These last two challenge problems, the hint is that you need to multiply both equations by something. So for instance, there's nothing that I can multiply 3 by to make it turn into 8, unless I want to start doing fractions, which you can definitely do. But I think it would probably be easier if we multiplied both of these by something so that we could get either the same number of x's or the same number of y's so that they cancel out. So try and figure that out.